In this video, we will generate the dataset of the ARCTAN and its polynomial and trend line using Taylor-Maclaurin series sum in two forms. So begin with the dataset of the ATAN. So array formula, ATAN x from -1 to +1. And we'll chart this. Insert scatter chart. Scatter chart. And show trend line, polynomial to the 6th or to the 10th degree. For the label, use the equation. And the legend, position at the bottom. Here's a trend line and polynomial to the 10th degree. We continue with the Taylor-Maclaurin series sum in the two forms. We begin with this form, where n is from 0 to infinity. So start from 0 up to infinity, which is 16, which is good enough. And the value of A1 is array formula, -1 to the power n, divided by the quantity 2 times n plus 1. Now we complete the Taylor-Maclaurin sum of the first expansion. So array formula, series sum of the x values raised to the power 2n plus 1. So where n starts from 0 to infinity. So at 0, 2 times 0 plus 1, so 1. So the starting point is 1. Continued by 2 times 1 plus 1, 3. So 1, 3, 5, 7, 9. So the increment is 2. And the coefficient, this range, A1. And next is the second expansion, where it begins from 1 to infinity. So the coefficient will be array formula, -1 raised to the power quantity n plus 1. So that's n plus 1. So this should be G4. And plus 1. And divided by the quantity 2 times n, where n is from 1 to infinity, 1 minus 2n minus 1, 2n minus 1. That's our denominator. So these are exactly the same. Now we continue with the Taylor-Maclaurin series sum. So array formula of the x values raised to the power 2n minus 1. 2n at n equals 1, that's 2 minus 1, 1. So starting point is 1. Then followed by 2 times 2, 4, minus 1, 3. So 1, 3, 5, 7, 9. The increment is 2. And the coefficient, it will be this range. This is series sum. So I forgot the series sum. Series sum. Now that should be correct. So these values are almost the same. We continue with the chart. We show the polynomial. In the series, there's no yellow. Change this color to green. And for all series, show a trend line polynomial to the 10th degree. And for the label, use the equation. So here, now we have the polynomials to the 10th degree and the trend lines. The values are the same, almost the same. So we calculate the polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix, starting with the power, transpose 0 to 10, and the elements of the matrix. This is equal to array formula of the x values raised to the power 0 to 10. So we calculate the polynomial regression coefficient LINEST dot y comma dot x. That's for the ATAN or the arctangent. This would be LINEST dot y and dot x comma dot x. This is for the first expansion. So the third, this will be LINEST dot y and comma dot x. Let's compare our polynomial regression coefficients against our polynomials on the chart. So x to the 0 coefficient 0, coefficient of x 1, coefficient of x squared 0 is 0, coefficient of x cubed minus 0.332, minus 0.336, minus 0.328, coefficient of x to the fourth 0, coefficient of x to the fifth 0.189, 0.223, 0.152, coefficient of x to the sixth 0, 0, coefficient of x to the seventh minus 0.0985. This time there's a difference now, minus 0.193 and 1.56 times 10 to the minus 3. Coefficient of x to the 8th 0, coefficient of x to the ninth, that's 0.0275, 0.106, 0.106, and negative 0.056. Coefficient of x to the 10th 0. This completes the use of the Taylor-Maclaurin series sum expansion, where n is from 1 to infinity, or the n is from 0 to infinity, to generate the trend line and polynomial of the arctangent function.